Alright gang, we're gonna pick up with the trig. We're gonna pick up with the trig here. I wanted to just do a few more examples before we moved on from the last video. So I like this example because you have to be really clear on who's the outer layer and who's the inner layer. So I'm going to start by just rewriting this example. So for the first example, the cube root is actually just on the x. If it helps you see it better, I could put little like light parentheses here. So the 1/3 is just actually on the x. Whereas in the second half of this problem, the 1/3 is actually on the trig. So you can write it like this, or if you prefer, some people, their brains like it better like this. Okay? The 1/3 is actually on the whole thing on the second one, and it's just on the inside on the first one. So that's going to really affect how we take the derivative. So let's work on the derivative now. So it's outie times innie. So for the first half, the outside is the sign, right? The sign's like our skull, the x to the 1/3 is like our brain, right? This is the outside, this is the inside. So derivative of the outside is cosine of the inside, keeping the inside the same, right? That's the outer layer of the first one. Now I'm going to take the derivative of the inner layer. So it's going to be 1/3 x to the negative 2/3, because I have to subtract 1. So that's outie times innie. Alright, I'll make that look better in a second. Let me now go to this one. So now this one, the outer layer is a 1/3, so we have to do that first. So it's 1/3 sine. I'm going to write it here. I like this format a little better. But again, you could put parentheses up and the negative 2/3 out here. So that's the outer layer. Bringing the 1/3 down in front, subtracting the negative 2/3, because that's the outer part, times the inner layer, which is the sine. So derivative of sine is cosine. Now there's not much we can do to make this look very nice. It's a very fancy problem. But I will just work on it a little bit to make it look better than it is at the moment. It's quite a sight right now. There's certainly more you could do here. You could go with an LCD. You could take out a common factor. You know, there's more places to go, but I'm going to leave it here just to make sure we're clear. This negative means you flip it down. This negative means you flip it down, and this is really good enough right here. Just some basic simplifications. Again, you could go farther if you'd like. Alright, let's try this one, and I'll end the trig video here, and I'll just start doing some we'll just start doing some more examples that are a bit more complex. Alright, this one actually is complex. This one, first of all, you have to figure out how many layers you're looking at, right? So there's actually 3 layers here. Can you see it? Can you see the 3 layers? If I rewrite this, it's just a rewrite, I'm not doing the derivative. Alright, there's a square on the secant. And inside the secant, there's a, not just an x, it's a pi x, which makes it a composite. So this is a 3-layered composite. It's got the outer, the middle, and the inner. It's a 3-layer composite. There's a square on the secant, and inside the secant is not just an x, it's a pi x, which means there's been a function that's been shoved in the secant. Alright, let's try this derivative. Alright, outer layer first. So outer layer is the 2. You're going to bring the 2 down in front. Don't change anybody else. I'll just put it in brackets so you know I did that piece. That's the outer layer. That's the 2. Now remember, like I said earlier, once you do a layer, your brain has to be like, oh, okay, I did that. That's gone now, right? It's like with the Tootsie Pop, you ate that layer. It's not coming back. Yes, that analogy is re-arisen. Okay, now we're going to do this layer. Oh, you guys are going to love this. This layer, remember the derivative of secant is secant tan. So it's secant tan of this inside. Because this is the inside of this question. Alright, so here we go. The derivative of secant is secant tan. But it's secant tan of this problem. And this problem has an any of pi x. Alright, so that's the middle. Secant is secant tan of that any. Alright, so now we did that layer. That layer's gone. It's been consumed. I'm really running this analogy into the ground here. And then pi x, the derivative of that, is pi. Alright, that's it. That is the whole derivative. Whew. Almost ran out of paper. Now we're just going to make it look pretty. So 2 times the pi is 2 pi. And if you notice, you have 2 secant pi x's, so you can write it like that. 2 secant pi x's and 1 tangent pi x. And that's a really nice way to write the answer. Alright, gang. I'm going to end this video here. We'll pick up with some other stuff when I come back. Catch you. Bye-bye.